Okay. If you have any question from the past uh, lectures, please ask me. If you have any question, please ask me. Nothing? Okay. Last week, last duty of what? What duty, Surah? For similarity, just simply use the method in the book. Write a you can do. I ask you to work on 5 different tuples. Okay, you need to choose 5 different tuples. It's your it's your choice. You can select, for example, the first tuples, or you can select some other tuples. Then you can calculate the similarity by your hand, or you can write a program and find the similarity between those records using the program, the computer program. Okay, uh, there is no difference between them. You can do it by your hand. We had a similarity example in the book. Any program by computer, yes. Read the last part of chapter 2. Uh, that part was about that part uh, was dedicated to similarity and how we can calculate the similarity. Uh, just implement that method. Uh, Vector cannot give you similarity measures, but in Python or MATLAB, you can write uh, programs for this reason. Be careful. VECA, you cannot use VECA in all part of the assignment. Most, at least half of the homework can be in half of the homework. You can use VECA, but in the second half, maybe VECA can be used, or maybe yes, maybe no. For example, VECA cannot give you any information about the similarity between 2 different records. Okay, that is enough, or you need, is it enough, or I should explain more? Surah, is it enough? Okay. Remember that you are studying in a master period. Okay. You can ask me question and I will give you the answer. But sometimes, instead of asking me, you can ask Google. Google can give you uh, very useful information too. Right now, I'm trying to find a good link, extra link for you. Uh, for this reason, give me a second. Okay, if you write in Veka, if you could write in Veka, excuse me, if you write in Python, you can find very good libraries for this reason. Uh, I suggest you to see this link. Um, in this link, you can find some details about common similarity measures with some examples, and it shows that how we can uh, find and calculate the distance between two different, for example, lists. Using Python, and it shows you how you can use Python libraries for this reason. But especially if you are using Python, you can use this library, SciPy. In this library, you can find related similarity measures. For example, give this one. If you have Python, you can use check this code, for example, here in this link. If you check this link, you can find a very simple code to find the distance between two different records. Here in the example in this link, there are two different records or two different lists, and in one line, Python calculates the distance between those lists. Just in one line. The total line of this program is 4. Just in 4 lines, it calculates the distance between those two elements. Here, the dataset 1 and the dataset 2. Okay, so as a master student, please, sometimes Google your question. You can find very useful links in the internet. You are a master student. You need to do that to find your answers in the internet. You need to learn that. Okay, is there any question? Is there any question? More question? Okay. The exam? Which exam? Haydar Sadun, which exam? In this course, okay, let me explain. In this course, you have your final marks has 20 marks. Okay, your final marks is calculated from 20. Here, I will ask you to do 4 different homeworks. Each of them has 4 marks. The highest mark in this course is 20. I will assign you 4 different homeworks. Each of those homeworks has 4 marks. You will do those homeworks in your home. 4 times in 4 means 16 marks of Sorry for interrupt. I repeat again. The total score of this course is 20. I will assign you 4 different homeworks. Each of them has 4 marks. So you can get 16 marks before the final exam. And final exam has only 4 marks. Only 4 marks. In the final exam, I never ask you the detail of the algorithms. Or for example, I never ask you to calculate the similarity between 2 records or something like that. I never ask you. In the final exam, just I will ask you some basic concepts. For example, one question is this. Please name this. Give me the steps. Let me know the steps of a data mining process and explain each steps shortly. Just you need to say, okay, I need to select the data set, prepare it, and then applying pre-processing steps. After that, you need to apply data mining techniques, and after that, you need to visualize the final data and making the final report for the managers. And for each step, for example, for pre-processing, for applying data mining methods, or visualizing and writing the final exam, you need to write some explanations. Nothing more. In the final exam, I never ask you to calculate something. I never ask you. Just I will ask you some basics. The final exam just has 4 marks. It's completely theoretical. The final exam is just and completely the final exam is completely theoretical and completely about the basic concepts in data mining, not about the details of different algorithms. Because in this course, I will teach you lots of algorithms. And you cannot remember them, I'm sure, because I couldn't remember them myself. So in the final exam, I never ask you to apply different algorithms or calculating something else. I never ask you. But in the assignment, yes, I will ask you. In the assignment, I will ask you. But the assignment, you can do the assignment in your home. Each assignment will have 2 weeks of time to do. So you have enough time for that. And before each assignment, firstly, I will complete a chapter content. I will teach you content of a chapter. And after that, I will show you how you can use, for example, Veka to apply those algorithms in the chapter in a real data set, applying those algorithms in reality, making a homework, making a practice, and then I will ask you to do the assignment. So don't worry about the final exam. Just try to do the assignment in the best way. Just focus on the assignments and don't worry about the final exam. Okay? Okay. Any question? I know, you have a stress. I know you have a stress because of the e-learning method for teaching. Don't worry about that. How many jets you will take in the course? What do you mean by jet? By jet, Surah. What is jet? You mean projects? Oh, chapters. After finishing chapter 3, I should finish 3 more chapters. Chapters 6, 8, and 10. Here we will discuss about. I will talk about 3 more chapters. 6, 8, and 10. So just let me to continue the course. And if you have any question, okay, if you have any question, please ask your questions using the WhatsApp group, in the WhatsApp group, or during the first minutes of the course. Simply ask me. But I rather to answer your questions in WhatsApp because we have only two lectures in a week. This time is limited, but in WhatsApp you can ask your question whenever you want, and the other students can read the questions and the answers to maybe they have a similar problem and they find the answers too. And also, I know some of you learn to speak Farsi, so maybe you can ask your question in Farsi. Maybe. But in WhatsApp group, in our WhatsApp group or in the class, just please ask your question in English. Okay. Is there any question? Okay. Okay. Thank you. In the last class, in the last lecture, we talked about reducing number of features in a data set. But sometimes we can generate some new features. Why? Because in some cases, please note, in some cases, not in all of cases, in some cases, we can create a new attribute. This new attribute, can give us some more important information, and they can help me during I'm going toward my goal. As I said in the first chapters of this book, I said that when I'm starting a data mining project, I need to define a goal. And after that, I'm working toward that goal. So I should analyze, and sometimes I see that if I generate or I create a new feature, maybe that feature could help me toward that goal. How can I generate this feature? To create this feature, I should use the original data. Maybe I use original data to extract new attributes. Maybe, for example, in a specific domain I'm working, and I see that if I extracting a new attribute, for example, address. When I'm talking about address, in the address you have name of different streets, you have name of a, an area in a city, or you have name of the city, name of the province, name of the country. Maybe in some cases we could extract the name of the city. For example, each of you uh, are living in a different city, so I can create a new attribute about the city that you are living. I can extract this information, your cities, from your address. But if I have a city feature, that is more easier for me to know about your locations. It's a domain specific attribute creation, attribute extraction. Okay. Sometimes I can map one data from one space, map a data from one space into another one. In the last section, we talked about wavelength transformation and Fourier transformation. They are mapping systems, mapping methods. Sometimes I can create a new attribute completely by, for example, combining different features. I'm combining some features to create a new one. For example, date. I have three different features. One of them is day, the second one is month, and the third one is year. I can combine them together as a single attribute. Date. It's a combination from the year, month, and day in a single attribute. Or your student number. Your student number can be divided into three different parts. It consists of three different parts. The first 2 or 3 or 4 digits are the year that you enter into the university. The most left digits in your student number. Please, some of you write your student number here. Some of you, please write your student number. One of you is enough. For example, Haydar Sadun. Would you please write your student number here? Just if one of you write, okay. You're a student. Don't worry. This is a student number of. This is a student number. Look at this digit. This number. 399 is the year that you enter to the university in Hijri Shamsi calendar. Hijri solar calendar. Okay. Then I think 13166 is your let me check. Yes. 399 is your entrance year to the university. 13166 is your major code. You have a unique major code in the university in Iran. This code is 13166, and 044, the 3 digits in the right, are the code of a student in this major. As I see here, in student number combines 3 different information, 3 different features. The year that a student enters to the university, the code of the measure, a unique code of the measure, and a unique code for that student among his classmates in the class. Each of you has a unique code in your class. So using this strategy, we can create different attributes simply. Sometimes we have continuous value, and if we change continuous ones into discrete ones, we can create some new attributes. For example, age. Age can be a number between 1 to 100. For example, there are 100 different values are in this range between 1 to 100. But I can say that, okay, ages can be grouped into 4 or 5 different uh, categories. For example, one category is children, then we can find teenagers, then young, then mid-old, and then, for example, old people. I can create 5 different categories, and I can, based on the boundaries of those categories, I can put peoples in different groups according to their ages. This is a data discretization. I discrete that values in attribute age into 5, for example, different categories. I can apply a similar method for temperature, for length, and so on. So I can create new attributes using data discretization. Okay. Sometimes I can reduce amount of data using a representator element. What does it mean? Let's suppose that I have, for example, 1000 value. They are scattered in the space, okay? Instead of saving information of those points in the space, I can use regression methods and find a best fit line equation. And after that, instead of talking about those points, I can say that, okay, just simply use this equation to find that point. Simply, this line that I created by using a regression technique is a simple line with 2 or 3 or some parameters. And in this case, I don't need to save more information about points. Just I need to save the basic parameters of that line, nothing else. So I can remove the total data about those points in the space. Just simply I need to save parameters of that line. Sometimes I can use log linear models. Sometimes these models are parametric models. Parametric models means such as regression, means that the output of these models have some parameters. But we have some non-parametric models too. For example, when I'm using histogram, in histogram, we never use parameters. When we are trying to cluster, to applying clustering, when we are trying to do sampling. In these methods, we never need to know different parameters. Okay. For example, when we are talking about regression, we have different regression models. One of them is linear regression. In this method, we need to find a straight line. And then we only need to remember and save the parameters of that line, nothing else. But this line has the minimum distance from the points scattered in the area. Most of times, to find this distance, we are using least square method. Sometimes we can use multiple regression. Multiple regression means is useful in multidimensional feature vectors. Sometimes we can use log linear models. This is good for multidimensional probability distributions. This model can help me. For example, here, this is an example about the regression. You can see some green points here in this plot, and you can see a straight line in blue. This line has the lowest distance from those green points. The lowest distance from those green points. As I said, to find these distances, we need to use least square methods, least square error methods, because we can draw different lines. But here we, for example, we choose this line. Y is equal to x plus 1. Why this line? Why, for example, we didn't choose y equals to x plus 2 or x minus 1. Why we didn't choose those lines? Here we need to use this SQR method to calculate these distances. Distance from a green point to the blue line. And the summation of these distances must be minimized. So the line y equals to x plus 1 is the best line, is the fittest line. It's not completely, but it fits with those points. Fits means that its distance from those points is minimum. Okay. Here you can see some more information about linear regression. This one has a simple formula, and in multiple regression, we can see that the formula is a little larger than the simple linear regression. It has more information, and maybe it's a non-linear function. In multiple regression, the formula is non-linear. In linear, so we have a linear regression and we have a non-linear regression. And in log linear, we are using some probability about distribution of data. Distribution of data in a space. By looking at these equations, we can see that there are some specific parameters. For example, in the linear regression, we need to know W and B. In multiple regression, we need to know B0, B1, and B2 values. But in histogram, there is no parameter. Here we have a data distributed in range between 0 to 100,000, and they are grouped into some buckets, some bins. You can see them in different. So the only things that we should know about this histogram is that how we can find the width of these buckets. What about number of these buckets and their widths? If I know the width of each bucket, I can define the number of buckets in histogram. Just this item should be cleared. The partitioning rule for histogram to create a histogram is divided into groups. Sometimes we are trying to find buckets with equal width. Each bucket has a equal range, and sometimes each bucket has equal frequency or equal depths. Mostly equal width is used in different programs and tools. For example, if you use VECA when you are choosing an attribute in the pre-process tab, in the first tab, if you choose an attribute in the left corner, in the right corner you can see the distribution of data of that attribute in a histogram. The buckets of that histogram has equal width. In WhatsApp group, I will give you a link for you. I will prepare a link for you to show you how we can find those equal widths, for example. If I'm trying to create a histogram for myself, I can use those methods to find the equal width histogram, equal width buckets. Maybe I can choose them simply, but it's better to use standard methods to define these equal widths. Okay. One more non-parametric method is clustering. Instead of saving information about the points in the space, we can talk about their clusters. For example, my data are grouped into, for example, 3 clusters. I never talk about the information in different clusters. Just I know that there are three different clusters, nothing else. In chapter 10, inshallah, we will talk about how to create clusters. But shortly, I can say that to create a cluster, the data points in a cluster should be grouped together according to their similarity or their distance. The data in a clusters must have the maximum similarity or must have the minimum distance from each other. And the data in one clusters and with data in other clusters, they must have minimum similarity and maximum distance together. This is the rule for clusterings. The data in each cluster must be separated clearly from the rest of clusters, from the rest of data in different clusters. So we need to talk about clusterings and how we can clusters and something like that. In chapter 3, inshallah. In chapter 10, inshallah. The last parametric methods, okay, is sampling. Sampling means that I have lots of data. For example, 1 million records. But why should I choose all of them? Why should I keep 1 million records? I can select just some samples. Those samples can represent the whole data set, those 1 million records. So sampling means that obtaining a small number of samples to represent a big data set. It can reduce amount of data, amount of memory that we need during the data mining process. But the key principle or the keynote here is that we have to choose samples that they are representative of all data. For example, we have to choose 1,000 records, but those records should represent 1 million records. So the question is that how we can choose those records. One simple question is that, okay, choose them randomly. Yes, we can choose them randomly, but the result is very poor. The result of sampling can be very poor because maybe during the sampling method, we choose data from some groups and we omit some other groups because it's a random sampling. And then the performance of the final result can skew it toward toward some groups. So the better option is to develop and use some adaptive sampling methods. Those sampling methods should choose samples with some intelligence. Here we will talk about 4 different type of samplings. You can find other sampling methods in the internet too, but 4 different basic sampling techniques are these ones. Simple random sampling. Okay, simply choose some samples. All samples have equal probability for selecting. Okay. The second one is sampling without replacement. Sampling without replacement means that when I'm choosing an item, in the next round, I couldn't select that item again. In other words, I could choose each sample 1 times only. 0 or 1 times, not more. We have one more sampling method, sampling with replacement. In this case, after choosing a sample, then we should put it back in the population and give it a second chance for selecting again. So we can do sampling with replacement or without replacement. With replacement means that I choose a sample, and after that I will return it to the main data set, and again that sample has a chance to select again. But in without replacement, I couldn't select that sample again 2 times or more. One better sampling strategy is start with sampling. In start with sampling, firstly, we should partition our datasets. Firstly, we are partitioning our datasets, and then from each partition, we select some samples with some probabilities, I don't know. And after that, from those selected samples, I can choose some specific samples. It's more fair than the previous ones. And the skewed data cannot affect this strategy because I'm choosing samples from different parts. First, I make some parts, and I will choose samples from different parts. if my data is skewed, the probability of choosing samples from the dense area of data is higher than choosing samples from the rest of area. But using this stratified method, I can be sure that my data can be selected from all parts of the area, not only a concentrated area.